Hello students, here is Mr. Olalekan Sowunmi once again. You are welcome back to class. Hope this video meets you very well. Hope you are sound, hope you are learning, hope you are doing the right things at all times. Now if you haven't watched the last video, please get the link and then be sure you have that knowledge before you watch this particular video. Anyway, that was just a revision of quadratic equations using the factorization method and also the graphical method. This factorization method and the graphical method of solving quadratic equations. But that's in the last video. So today we need to move forward. And that's why you are welcome to this very class. You are welcome to this very class. God bless you. Now in the last class, let's do a quick revision of that. In the last class we had quadratic equations, and if you look at the screen, these are the things we discussed about quadratic equations. And we have previously two methods have been used in solving quadratic equations. That's factorization and graphical methods. And you can see that's the notes that we're using for this particular topic. So we have all this. This was not available in the last video. So this week you can have the notes and enjoy the class with me. So with what we have there, we have the same example that we used in the last video, which is x squared plus 8x plus 12. That was the particular example we used, and we solved it by factorization method, and also we solved it using the graphical method. We created a table last week. I noticed that for us to have the answer, the correct graph for that particular question, we need to start our range of values of x from -6 to 1, or even from -7 to 1 or 0, and so on. And this is what we have on our table. That's what we have on our table. And when I sketch the graph, that means you're going to have a graph that is starting from -6. From here you can see the curve. That's how the curve is going to look like a U. And we can see the values on the x-axis. Look at the color in yellow, the point in yellow on -6 and -2. So that is where the value of the quadratic equation lies. If you remember, when we solved using the factorization method, we discovered that the answer is -2 or -6. -2 or -6. So when you are going to solve that on the graph, nothing is going to change in the answer. It's still -2 and -6. So you can see that they are the 2 points that dropped on the x-axis, and those are the values of the x that we are actually looking for. So that's how your graph is going to look like when you draw it. So that is the quadratic graph. Now from the above diagram, the solutions of the quadratic equations x squared plus 8x plus 12 is at the point -6 and -2 on the graph. Now today, this is exactly where we are going. Other methods of solving quadratic equations, which are completing the square method and the quadratic formula. What did I say? Completing the square method and the quadratic formula. So sit back and let's try and enjoy the class. First, we shall look at a special case of quadratic equations, which is what we call perfect square quadratic equations. Now you can have every form of equations of quadratic, but there is one that we call the perfect square quadratic equations. Can you say that, please? Perfect square quadratic equations. For the last time, perfect square quadratic equations. Now quadratic expressions of the form x squared plus 2xy plus y squared and x squared minus 2xy plus y squared are known as perfect squares. They are known as perfect squares since X squared plus 2xy plus y squared is x plus y squared. You know, when you say x plus y squared, it means you are having a perfect square here. A perfect square. A perfect square. When you say 2 squared, the value you are going to have is a perfect square. Let me try and explain that using our board. Let's go back to the class and use the board. Okay, let's clear the board now. Okay, now look at the board. I was discussing about perfect square quadratic equations, and I gave you how it's going to look like, the form of a perfect square quadratic equation, which is x squared plus 2xy plus y squared. Let's leave it as an expression like this. So this is a quadratic expression, and it's called a perfect square quadratic expression. What you will notice is that we have x squared and we have y squared. And when you say x squared, let's say 2 squared. What would 2 squared give us? 4. 4 is a perfect square. So any number you square or any number you multiply by itself, it's a squared number. So when you say 3 squared, for instance, that is going to give you 9. And 9 is a perfect square. 9 is a perfect square. Can I hear you say 4 is a perfect square? Okay. And can I hear you say 9 is a perfect square? Okay, I know you are saying that in your mind. Okay, now so when you have perfect square like this, you have x squared and you have y squared. Those are one of the criteria for having a perfect square quadratic equation. Hope you get that. Another instance, we have positive value here and a positive value here at the same time. Another instance is when you have a negative middle sign. A negative middle sign. Let me show you that. We have x squared minus 2xy plus y squared plus y squared. So in this case, you have the middle sign here to be a negative sign. You can have it in this form as well. So we have a perfect square here, and we also have a perfect square here. So those are the two ways you can have a perfect square quadratic equation. Can I hear you say perfect square quadratic equation? Now let's say the equations together, the expression together. Let's say now x squared plus 2xy plus y squared. Can we say it again? X squared plus 2xy plus y squared. Okay, let's say the first one here, which is x squared minus 2xy plus y squared. Once again, x squared minus 2xy plus y squared. Now the second one, x squared plus 2xy plus y squared. So these are the two ways you can write your perfect square quadratic expressions. And when you have them as equations, that means it will be equal to 0 and this will be equal to 0. So we have them as perfect square quadratic equations like this. Can we say that? Perfect square quadratic equations. Now I hope you are following the class. Okay, now in order to any expression that is a quadratic expression, we should be able to factorize at least some of them. So for a perfect square quadratic expression, you can always factorize them, and they are very easy to factorize. I know you love to hear easy in mathematics, so they are very easy to understand. So let's just look at how we can factorize a perfect square quadratic expression. Okay, let's look at the board. Let's say we have x squared plus 2xy plus y squared. This is the first one I gave to you the other time. Okay, 2xy plus y squared. Now look at this. Let me give you an instance. When you say 2 squared, which will give you 4, right? If I find the square root of 4, that will give me what? That will give me 2. This same number, that same number that you squared. When I say 3 squared, I have 9. If I find the square root of that 9, I have what? I have 3 back. I have 3 back. Can you see that? So the same number that you squared. So when you square x and you find the square root of x, what are you going to have back? You have x. Okay, let's go. We are moving. We are getting somewhere. Let me clean the board. Next time, I may appoint some of you to come and clean the board for me. So make sure you have your own digital cleaner to come and clean that for me. Okay, let's continue. Now you can see we have x squared. Now all you need to do now is to get the square root of this x squared. Okay, let me try and do that. What is the square root of x squared? That will give me x. What is the square root of this our y squared here? That will give me let me try and do that. Y squared, the square root will be y. So in order for us to factorize this quadratic expression, just have the square root of x squared, which is x, then use the sign, the middle sign, the sign you have with the middle term, which is plus here. No, we are not considering this second sign, we are considering the middle term sign. Can you see that, which is plus? You put it straight, plus, then we have y, which is the square root of y squared. So you have, that means we have square root of x squared plus square root of y squared. That will give us x plus y. Then the moment you do that, put a bracket and square it. So it means if you are asked to factorize this particular expression, the answer you are going to get as your factorization is what we have here, x plus y squared. Can we all say that? The factorizing x squared plus 2xy plus y squared gives us x plus y squared. Hope you get that. So the other one where you have minus at the middle, let me change our sign now. I'm cleaning the middle sign and I'm writing minus here. For us to factorize this, all we need to do is to do the same thing we did in the first one. Open your bracket, square root of x squared will give you x, square root of y squared will give you y, but this time around the middle sign will be minus. So minus y, then you square it. Is it not easy? Is it not easy? Now you may decide to want to use the factorization method to solve it, and you still get the same answer as this. So this is how to factorize a perfect square quadratic expression. And so when you are solving a perfect square quadratic equation, you should know that you have to first factorize and get something like this out, then you continue to solve to find either x or any other variable you are given when you are solving the perfect square quadratic equation. I want to believe this is understood. I want to believe you understand how to factorize a perfect square quadratic expression now. Let's move back to our notes quickly. Are you with me? Okay, or you want a recess? I packaged something for your recess, don't worry, just stay with me. We have packaged something for your recess. Now, perfect square quadratic expressions is what you already have here. You can see that we have, for example, now a quadratic. Now you can see this is the solution I gave you then when you factorize this quadratic expression, x plus y squared, x minus y squared in brackets. Now a quadratic expression is a perfect square if and only if. Now we have two conditions. Maybe I should not have used if and only if. I should have used just if there. So when you are writing this note, just put if. When I say if and only if, maybe I should just put one condition where I'm not an English teacher. Now, if one, the first and the last terms are perfect squares, just like in our example, the first term is a perfect square. The last term, what do we mean by first term? Let me show you that in our on our board. Let me show you that on the board. Now look at the board. We have x squared here. Can you see x squared? And can you see this? Can you see this? This is your first term. This x squared is your first term. The one at the middle is your middle term. The one that is here is your last term or your third term. This is your second. The middle term is also your second term. So the first term must be a perfect square, and then the second term must be the last term, which is your third term, must also be a perfect square. That is the first condition for an expression, for a quadratic expression to be a perfect square. Do you get that? That is the first condition. Let's go back to the notes. So we'll be migrating from notes to the board. That's exactly what teachers do, right? Now, if you look at the note now, you will notice that a quadratic expression is a perfect square if the first term, can you see the first term and the last terms are perfect squares. Number two condition is the middle term is twice the product of the square root of the other two terms. So what do we mean by this? The middle term is twice the product of the square root of the other two terms. Let's say that and understand that. The middle term, okay, can I hear someone say that? Is twice the product of the square root of the other two terms. It looks cumbersome. The middle term is twice, that is 2 times the product of the square root of the other two terms, that is the first term and the last term. Let me show you what I mean by that on our board. Are you ready? Now look at the board. The middle term, these are middle term. Let me clean this place so that we can have a space. Now let me get the middle term for us. Look at the middle term. Look at this middle term. Minus 2xy. Minus 2xy. Now they said the middle term must be twice, which means let's write our 2 first. Twice. When you say twice, that is 2 times something. Twice the square root of the other 2 times. What's the square root of x? X squared. The square root of x squared is what? X. And the square root of y squared is what? Y. That is why you have the middle term as 2xy. 2xy. That's what you have here. So when you square root the first term and you square root the last term and you multiply it by 2, that is what that long sentence is simply saying. The middle term is twice the product of the square root of the first term and the last term. I hope you are enjoying the class. I need to ask that. Okay, stay with me. Okay, let's look at some examples here. Look at this example. For example, which of the following are perfect squares? Now, you are going to be tasked to do something now. Hope you are ready. Which of the following is a perfect square? Number 1, we have u squared minus 14u plus 49. U squared minus 14u plus 49. Number 2, we have 6x squared plus 13x plus 16. Number 3, we have 2b squared plus 5b minus 7. And number 4, we have m squared plus 2mn plus n squared. Okay, number 1, we have this. U squared minus 14u plus 49. Can we use the board? Let's clear the board. We have u squared minus 14u plus 49. Now anytime you want to check whether something is a perfect square or not, all you need to do is to what? All you need to do is to check the 2 conditions I gave you earlier, that the first term and the last term must be a perfect square and the middle term must be twice the product of the square root of the first and the last term. Let's check this one, whether it's a perfect square quadratic expression. Okay, the first thing now is the first term, is it a perfect square? The first term is u squared, so u squared is a perfect square, so we can give it a tick. It's a perfect square, so u squared is perfect square. Then look at 49. Now let me try you. Is 49 a perfect square? Since 49 can be written as 7 squared. 7 times 7 is 49. So 49 is a perfect square. It's a perfect square. Okay, do we get that? Is a perfect square. Okay, so it means therefore that the first term and the last term are both perfect squares. So let's check the last condition for it to be a perfect square. The last condition is that the middle term, this middle term must be 2 times square root of this and square root of this. 2 times square root of u squared and square root of 49. So that means we are going to have 2, that's right, 2 times, what is square root of u squared? Definitely u, then times the square root of 49 is definitely 7. So 2 times u is 2u, then times 7 we have 14u, which is exactly what we have at the middle. So it means u squared minus 14u plus 49 is a perfect square quadratic expression. I hope you understand that. Then look at 6x squared plus 13x plus 16. Let's see how this is a perfect square or whether it is not a perfect square. We have, let me clear the board. We have 6x squared plus 13x plus 16. Okay, so our condition, the first condition is that the first term and the last term must be a perfect square. Now in this one, x squared is a perfect square, but is 6 a perfect square? That is a no. We have the perfect square from 1 to 100. 1 is a perfect square. Let me help you a little. 1 is a perfect square. 4 is a perfect square. What else? What else? 9 is a perfect square, 16 is a perfect square, 25, 36, 49. Just keep multiplying each of the numbers from 1. 1 times 1 will give you 1, 2 times 2 is 4, 3 times 3 is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and it goes on and on and on. 8 squared it's 64, 9 squared 81, 10 squared is 100. So these are perfect squares between 1 and 100. So between all of these, we can see 6 there. So this is not a perfect square. So if this is not a perfect square, forget about the other conditions. The whole expression cannot be a perfect square, even though 16 here is a perfect square. Can you see that? But because this is not true, then the whole expression is not true. So 6x squared plus 13x plus 16 is not a perfect square quadratic expression. Okay, do we get that? Then the next one is m squared. Okay, 2b squared plus 5b minus 7. 2b squared plus 5b minus 7. 2b squared plus 5b minus 7. Now, is this a perfect square quadratic expression? Let's check. Okay, I'm sure you are already nodding your head, or either you are shaking it. Nod, shake, nod, shake, shaky, noddy, shake, nod. Okay, don't mind me. I love to sing at times. Alright, 2b squared plus 5b minus 7. Is this a perfect square quadratic expression? Let's check. No, actually, b squared is perfect square. But 2 at the back here is not a perfect square. Assuming you have 4 here, that would have been lovely. The whole expression here would have been perfect square. Now, also, 7 here is not a perfect square. And if the first condition is not true, you don't need to go for the second condition. That will not be true as well. So 2b squared plus 5b is not a perfect square quadratic expression. Okay, do we get that? Do we get that? Okay, the last one. Let's quickly get the last one for this first video. So m squared plus 2mn plus n squared. M squared plus 2mn plus n squared. From what you have here, m squared is perfect square, n squared is perfect square, 2mn is also twice the square root of the first term and then the last time. In other words, the square root of m squared is m, the square root of n squared is n. Then multiply it by 2, you have 2mn, which is the middle term. So this one is a perfect square quadratic expression. Perfect square quadratic expression. I would like us to go for a recess now, and while we are going for the recess, I think we are going to.
Sorry, ntí mo fẹ́ mọ kọ́ nísìn mathematics ni torí ọ̀pọ̀lọpọ̀ èèyàn inú wọn fi ìpínlẹ̀ pé ìyìn kọ́ mathematics kébí pé English nìkan ni àyànmọ́ mi ọmọ kéré mo ti wáyé mo wà fàírà kò sí tí ìlẹ̀ kọ́ mo lè kọ́ chemistry o biology o anything mo lè kọ́ àmọ́ lónìí mathematics mo fẹ́ kọ́ yín ṣé wá rí nínú mathematics àwọn terms ọwà term tí wọ́n máa ń lò nínú mathematics àwọn term wí. first time
Okay, I hope you enjoyed the video. Don't worry, you will enjoy the video in the next video that we are going to send. For now, we are going to stop here and join another video with this. Thank you for your time. God bless you.